Now something we're asked quite a lot is, can I run both UFS and UniPro in the same test? And the answer to that is yes. So to do that, we're going to create another new test. When you want to do both UniPro and UFS, you have to create a UFS test, because UFS is a subset and it's sent via UniPro data packets. So I have to have both UFS and UniPro, and the only test that does that is a UFS test. So I'll go to Test Editor. I will select New, UFS Stimulus, and I'm just going to call this UFS UniPro Demo. So we're going to do both UFS and UniPro in this same test. I'll select my Stim Demo test category, and I'll hit OK. So again, once my test opens, the file I care about is usertest.cs. So we'll bring that up, scroll down to our test body, and we're just going to delete all these comments here, except for the reboot. We're going to go ahead and allow the UFS reboot to stay. Now for this test, I'm going to combine both UniPro and UFS. I'm going to do some power mode changes, which is a UniPro thing, and then run some read and write attribute data through the UFS engine. I'm also going to use a little bit more C# syntax so that you can kind of familiarize yourself with a little bit of that. So the first thing I want to do is a power mode change, and I'm going to have the power mode change several times during this test. We have a power mode config class that you can set up with all the things you need in order to change your power mode, and that object is called power mode configuration. So I'm going to create a new power mode configuration, and I'm just going to call it power config. Now before I can use this, I actually need to set it up as a new class, otherwise it'll just be a null object. So to do that, you say new equals new, and in this case it's a power configuration. It doesn't take any parameters, so you just have to do an open and close parenthesis and then a semicolon. And so now I have a new power config object I can use. This power config object gives me access to all the different pieces and parts of a power mode change so that I can set it up and then use this to initiate a power mode change. So what I want to do is I'm going to copy this power config object so I can use it several times here, and I'm just going to type power config dot, and I need to set a few things. So the first thing I want to set up is my TX mode, and I'm going to set my TX mode equal to, and now here's some of those shared type enums that we had mentioned in the documentation way back at the beginning. So you'll see here this is recommending that I use mode because it's a TX mode. So if I hit tab period, it will show me all the modes that I have available. So I can select fast auto. Now all this mode is a C#, it's called an enumeration. An enumeration is really just a list of integers, but they're accessible with a nice friendly name. So if I click mode and hit F12, it'll take me to the definition of that particular enumeration. So you can see mode is a set of fast, slow, fast auto, slow auto, and unchanged, and they have values of 1, 2, 4, 5, and 7. I could pass around 1, 2, 4, 5, or 7, so for fast auto I could pass a 4, but it makes much more sense to refer to it in my code as fast auto. I know what it is, it's more human friendly. So I'll just go ahead and close this tab. It takes me back to my test. And again, to look at that definition, it's F12, or you could always right click and select peak definition, which will show it to you right here in line, or right click and say go to definition, which is the F12 shortcut I just showed you. So I want my power config to have a fast auto mode. I want it to use 2 lanes. So I type power config dot tx lanes. And tx lanes I'm going to set equal to, and I get another enum, lanes dot 2. And so now I'm set it up to use 2 lanes. Now I need to configure this on the RX as well, and I want it to be the same. So I like copying and pasting when I'm writing scripts. It saves me a little time. So I'm just going to copy that down here, and all I have to do is change that T to an R. And then I've set the RX mode, and I've set the RX lanes. And again, you could always go back, type your period, see that you can scroll down and pick RX lanes right here. Either way, I like to save time by copying and pasting things and using IntelliSense as much as possible. So now I'm going to put both my TX and RX into fast auto by 2. Okay, I want to configure a rate series as well. So I'll just go ahead and type power config.rate, and that's going to equal, again, it's going to recommend it rate.b. So IntelliSense is really guiding me through this and helping me without having to look at the documentation, which is great. Now you'll notice the one thing I haven't set yet is my gear. I have a by 2 fast auto rate B, but I haven't set my gear. I'm going to do my gear dynamically, and I'm going to change to 3 different gears. So I'm going to do that by looping with C#. So to do that, I'm going to use a for statement. Now this is a C# specific syntax, but I will explain it as I walk through. So for, what you have to set up is some sort of an iterator, something that this is going to loop over. And so in this case, that's going to be an integer. So I'm going to define an integer, name it I, and I'm going to set it equal to 1 initially. That's the value that you want to have the for loop iterating over. Now, how long does it iterate? This integer I is set to 1, so that's where it'll start. And if I type semicolon, the next thing I have to tell it is how long I want it to loop. Well, I want it to loop while I is less than or equal to 3. So that means as long as I is less than or equal to 3, this loop that we're creating will continue to loop. The last thing you specify is what to do at the end of the loop to my I value. And in this case, I want it to go up. So I'm just going to type I plus plus. Then it's an open curly brace, and all the code in this curly brace now, between these 2 curly braces, will loop over and over. I will be equal to 1 the first time. It'll then get incremented to 2. It'll then get incremented to 3. And as long as I is less than or equal to 3, this code will continue to run. So that's what we're attempting to do here. So the thing that I want to have happen first off is I want to change my power mode. So I want to set power config dot tx gear, and I want to set that equal to my current value of I. But you'll notice if I type equals I, it tells me that that's invalid. But you'll remember that the enums that we have available are all integer backed. So gear wanted to use the gear enum. So I could type gear dot, and I could select 1, 2, 3, 4, 5, 6, 7, whatever I want to do. But in this case, I want to go to gear 1 because gear 1 equals 1. And you'll see here if I go down to 1, it even tells me over here gear 1 equals the value of 1. So I can specify gear as an integer, but I just have to tell the application that what I want is actually a gear enum. So to do that, we're actually going to use what's called a cast. So to cast, you put the thing you want to cast to. So I want to cast my integer into this gear enum in parentheses. And then the value that follows that last parenthesis is the value you want to change. So in this case, that's going to be an I. So what I'm now telling C# is to take I, make it a gear, and set tx gear. So in this case, I'm going to set my gear to 1. I also need to set my rx gear. So I'm just going to copy that line, change the T to an R, and now I've set my RX gear. So now I have this power config all ready to roll. It's gear 1 fast auto by 2 rate B. I need to now actually set that by using the UniPro Tools. So what I'm going to call is a method from my tools collection. But again, like I did before, just to make this less confusing, I'm going to rename tools to UniPro Tools so I can see in line which one I'm calling. So we're going to make a call here to UniPro Tools, and I can scroll down to my IntelliSense, hit tab, dot set power mode. And what do I want to set the power mode to? I want to set it to all this stuff that I've already configured in power config. So I just have to give it this power configuration object. So I'm going to do open paren, and you'll see that it even asks me for my power mode configuration. So I'm just going to pass in power config. So that's going to go ahead and change my power mode to HS gear 1. Now the second time this loop iterates, the only thing that's going to change is this TX and RX gear. All this will be left alone. TX and RX gear will now be set to 2, and then I can recall set power mode, and now it's going to change to HS gear 2. and the third time through it'll change to HS gear 3. So that's just going to basically iterate change power modes 3 times. Now each time that I change power modes, I want to go ahead and run some set of code. And in this case, what I'm going to do is just copy and paste. This is the exact same code we wrote for the UFS demo. So I'll just paste this in there. And if you didn't watch the UFS demo, I'll run through this really quickly. And we're going to go ahead and delete the write line commands, because in this case, we're not going to worry about debugging. We're just going to look at the results in the packet window. So I'm just going to remove these lines. So this is exactly what we did in the UFS demo. I'm going to use the UFS Tools to read attribute 0, which is boot LUN enabled. Then I'm going to use write attribute to write that attribute to a value of, in this case, we're going to write that to a value of 1. And then we're going to read the attribute to verify that that attribute value did in fact change. So we're going to read it, write it, read it again to make sure that the value changed. Now because we're doing this as part of our for loop, this is going to change to HS gear 1, run this code. Then we're going to come around, use our UniPro Tools to change to HS gear 2, and we're going to rerun this code. And then we're going to come around again and change to HS gear 3 and run this code a third time. So we should see this series of reads and writes happen 3 different times. Once this is done, this returns true, meaning the test succeeded. Now one thing we have that's new with 2.02 or higher is the ability to change the message that's written out to the application software. You do that using your test context. So test context, not only does this provide information from the app, but it allows you to provide some information back to the app. So once this loop is done, what I want to do is just set the context dot, and it's actually called error, but really it's just the context dot error string that gets printed out. Doesn't necessarily mean that there was an error, it's just called error. And so what I'll type in is finished stimulus test. So I know that my test finished, semicolon. And then I need to tell it what type of message this is. So again, if I type context dot test error level, I can set that to this error level enum dot el, and we'll just say none. So there was no error, so it should just print the message finished stimulus test, and then it will turn true. So remember, this is new with 2.02 or higher. If you're still running an older version, you may not yet have this ability, but the rest of this should work for you just fine. So a slightly more complex stim test case, but we've successfully configured both UniPro and UFS commands, and we've done a power mode change, and we've used a C# for loop to go ahead and iterate and do this 3 separate times. So we'll hit save. And again, before this is going to be ready, we have to build it. So we will go to test editor and we'll select build stimulus. We get our build 1 succeeded, that's what we want to see, and we'll flip back to the application software. So I'm actually going to flip to the UniPro packet list for this just for a second, and you'll see we have our UFS UniPro demo. So that's the test I'm going to select, and I'll start the analyzer. I'll run our stimulus, and we'll go ahead and stop the analyzer. So you'll see we've got a few power mode requests here. And the data was sent. So let's just go to this first power mode request, and you'll see here, if I expand this, that this was slow auto gear 1. So this was the application putting itself back into PWM gear 1 for the very first power mode request. Let's go to the second one. The second power mode request you'll see is our fast auto by 2 gear 1. So this is it requesting high speed gear 1, and you'll see I do go into high speed gear 1 by 2, and then I start sending some data frames. So that's our first power mode request, and then we see UFS data. We should then see another power mode request for gear 2 and gear 3, but I just want to flip over to the UFS packet list and take a look at what happened there. So here's the boot. I'm just going to go ahead and click this to go to the end of our trace, and I'll expand this up a bit. And you can see, because we should have a power mode column, I'll make this a little bit smaller, that we are in HS gear 1, and here's our read, write, read. Just like we did before, we read the attribute, we wrote the attribute, we read it back. You can see then we go to HS Gear 2, we read, write, read, and then we go to HS Gear 3, and we read, write, read. So that's the result of our iteration and our looping. We've only touched on the surface of the power of what you can do with the stimulus tools. So I encourage you to go read the Stimulus User's Guide and also spend a little bit of time in that Stimulus API reference. And again, those can be found on the Test Editor menu, Help. You have your UniPro Stimulus Editor Manual. The UFS Stimulus Editor Manual will be up shortly. And then you have the Stimulus Editor API documentation, which will really tell you all the different methods and properties that you can run in both your UniPro and your UFS tool sets.